So you finished chapter 1 and now we're moving on to chapter 2. The first lesson in chapter 2 is on properties and operations, and there's a lot of vocabulary for this section. But rather than write all the vocabulary out, I've kind of arranged it in a table. It may seem confusing because these are kind of bigger words and words you don't always use, but you probably have used all of these properties. So for example, the commutative property of addition means that in a sum, you can add the numbers in any order. Just like you could add 4 plus negative 7 or negative 7 plus 4. It doesn't matter which order you add in, it's going to end up with the same answer. And in the algebraic terms, you can write a plus b or b plus a, you're going to get the same answer. There's also the commutative property of multiplication. It's the same thing. In a product or multiplication problem, you can multiply the numbers in any order. So you could say 8 times negative 5, or negative 5 times 8, or a times b and b times a. That's because the order doesn't matter in these problems. And I believe you're familiar with this. But it's not the case when you have subtraction and division. And we'll get into that later. But the associative property is that you can change the grouping of numbers in a sum and it doesn't change. Because you can add them, because of the commutative property, in any order, we can group addition problems differently and it's not going to change. 9 plus 6 and plus 2 is the same thing as 9 plus 8, which is the 6 plus 2. So it doesn't matter how you arrange the grouping symbols. So you could say a plus b and then add it to c, or you can do b plus c and add it to a. They're both the same. And the same goes with multiplication. And this is all because the order doesn't matter in multiplication and addition, because you're always going to get the same answer. So you can change the grouping symbols, which is the associative property, or you can change the actual order of the numbers, which is the commutative property. Hopefully, try to come up with a way that you can remember the commutative versus associative with like a word association, and bring it with you to class tomorrow. So let's use a problem that uses the properties of addition. So you listen to a radio for 27 minutes on Monday, 9 minutes on Tuesday, and 13 minutes on Wednesday. Find the total time you spent listening to the radio. So in this case, the total time is the sum of these 3 times. So if we add these 3 times together, we should be able to get the answer. Use the properties of addition to group together times so it's easy to add mentally. This helps with mental math. It's a lot easier to add things together that make sense. So if you had 27 plus 9 plus 13, we can either change the grouping or the order. So in this case, we use the associative property. So 9 plus 27 plus 13, 27 and 13 are easy to add up because it's going to be an easy number, because 3 plus 7 is another 10, so you end up getting 40. So 9 plus 40 then equals 49 minutes. It's a lot easier to do that than add 9 to 27 and then add 13 to that. So the whole point is how can we group it or change the order. So you can kind of see we did change the order and the grouping here. 27 came over to the middle to be closer to 13. They were grouped together, so we did that first and then added the 9. The second, let's do the same thing but using multiplication. So if we had the problem 2xy when x equals 8 and y equals negative 35. So first step, we always want to substitute for x and y. So 2 times 8 times negative 35. Remember when we use these parentheses and there's nothing else in between them, it means multiplication. So here, I decided to group the 8 and the 2 together because to me it's easier to multiply 8 times 2. So here we get the commutative property of multiplication because we changed the grouping. But actually I changed my mind. I don't think the 8 and the 2 are easier. So I'm going to change my grouping again, even though I changed the order, to be 8 times 2 times negative 35. Do what's in here first. 2 times negative 35 is going to be negative 70. 8 times negative 70 is easier, so negative 560. So you can change your mind and fix it as you go. In this case, we switch the order, which is the commutative property. So the 8 and the 2, we swap sides, and then we change the grouping. So take a few minutes and try the following 4 problems. Use mental math, meaning don't use a calculator. See how can you rearrange these numbers or add grouping symbols to make it easier to do. So make sure you show your work. Don't just write the answer. The important part here is I want to see how you're using these 2 properties. So press pause now and work on them. So now, since this is pre-algebra, we're going to use variables, or those letters. So we're going to use these properties to simplify an expression. So here we have 21 plus 3 times 8y plus 30. And we want to simplify it. So in this case, we can say, I did not do this right. Hold on 1 second. I see what's the matter. My multiplication went away. So my little dot here. So we have 3 times 8 and then times y plus 30. So then that simplifies to 21 plus 24y. We still keep the y there because it's just multiplication, and you can multiply in any order. So you could have done 8 times 3 times y, 3 times 8 times y, and the y just stays there. Then we can reorder this, so we can add the 21 and the 30 together through the commutative property. Then the associative property, we put parentheses around it so it's grouped together. And then lastly, we can say 21 plus 30 equals 51. So as simplified as this term can get is 24y plus 51. We can't add the 24 and the 51 together because the 24 is multiplied by y and the 51 is not. So try to simplify these 2 expressions. Press pause now. Okay, so we have 2 more properties, and it's called the identity property. So the identity property of addition states that the sum of any number and the additive identity, which is 0, is the number. You should know this. Any number plus 0 is still that number. So even if it's a negative number, it stays negative. If it's a positive number, it stays positive, but it's always that number. So this additive identity is 0. Now the identity property of multiplication, the multiplicative identity is 1, because if you multiply any number times 1, it's still that number. So you can see 4 times 1 is 4, and a, which can represent any number, positive or negative, is also a. So the last example is going through multiplying by a conversion factor. We've used this in science a bit, but when you need to change the units of things, or change it from tons to pounds, or meters to feet, you use a conversion factor. So in this case, the African elephant is the largest living land animal. Its average weight is 6 tons. What is the African elephant's average weight in pounds? So first, we need to find a conversion factor, or that number that converts tons to pounds. So in this case, 1 ton gives you 2,000 pounds. So it kind of gives you a conversion factor. So if we know 6 tons is equal to 2,000 pounds over, and this should not be, this should be a multiplication symbol. So 2,000 pounds over 1 ton, these are equal. So it's like multiplying by 1 over 1. So in this case, we're actually converting the units. And tons will then cancel out, because 1's on the bottom. Tons divided by tons cancels out. So 6 times 2,000 will then convert the 6 tons into pounds. So you get 12,000 pounds. So another example is how can you convert 3 hours into seconds? This takes 2 steps. So the first is 3 hours times, I'm sorry, I made mistakes in making this, times 60 minutes over 1 hour, because we know 60 minutes are in 1 hour. We want to cancel the hours out. That's how we know that hours goes on the bottom and minutes goes on the top. So our hours cancel, but we want it in seconds. So now that we have it in minutes, we know there's 60 seconds in 1 minute. So our minutes can cancel, and we're only left with the units and seconds. It's important when you do these problems to write out the units and actually cross them out, so you know whatever's not crossed out, those are the units that are left. And then we can multiply across the top, multiply across the bottom, and divide. So in this case, we get 10,800 seconds. 3 times 60 times 60. So try this. Use a conversion factor to convert 3 years into months. And bring this with you tomorrow. That's the end of section 2.1.